The first credit in the Indoor Environmental Quality section of LEED, New Construction Major Renovation, is Outdoor Delivery Monitoring. There's 1 point available for new construction, schools, and Cornshell. The requirement is to install permanent monitoring system to ensure that ventilation systems maintain minimum ventilation requirements. The equipment must generate an alarm when the airflow values or CO2 levels vary by 10% or more from the set point, to alert the building operator or provide visual or audible alerts to the building occupants. This can be integrated with a control system as well. You can see in the image this automated ventilation device above an atrium. The requirement for mechanically ventilated spaces is to monitor carbon dioxide concentrations within all densely occupied spaces. This is considered to be spaces with 25 people per 1,000 square feet. Locate monitors between 3 and 6 feet above the floor. This is considered your breathing zone. And for systems where 20% or more of the airflow serves non-densely occupied spaces, should provide a direct outdoor airflow measurement device capable of measuring the minimum outdoor air intake flow with an accuracy within 15% of the ASHRAE 62.1 requirement. So those percentages in yellow are important to memorize. Once again, this is a very technical section and requires a lot of review. You do need to memorize things like what densely occupied space is, that 25 people or more per 1,000 square feet, and that the breathing zone is within 3 and 6 feet above the finished floor. For naturally ventilated spaces, you need to monitor carbon dioxide concentrations. So locate within the breathing zone, which is that 3 to 6 feet above the floor, CO2 sensors. One CO2 sensor may be used to represent multiple spaces if the natural ventilation design uses passive stacks or other method to induce airflow. So there's an example of a passive stack in that diagram where there's air passing through and funneling through that vertical area on the left. This can be combined with atriums or vertical circulation such as stairwells. There's also a fan inducing more airflow in the top right. The red showing that hot air rises, so once it heats up indoors, it's more likely to be sucked out through that stack ventilation. Next slide. There are very strict requirements in meeting the outdoor airflow monitoring criteria for this credit. You cannot use air balance control methodologies such as fan tracking and measuring building pressurization. Instead, you need to measure the ventilation rate at the outdoor intake areas. And there are a few airflow devices that can help you make these measurements, including pitot tubes, Venturi meters, and rotating vane anemometers. So remember, whole building pressurization air balance control methodologies do not comply to meet this credit. That's one of those technical questions you may get. So you don't need to necessarily memorize the actual devices themselves, but you have to understand the criteria differences and what does not satisfy this credit. So CO2 sensors that measure concentrations to provide an alert usually start at indoor concentration of 1,000 parts per million. At that point, the alarm will go off, but higher standards can also be set. A single CO2 monitor is typically installed in the return air duct, although multiple sensors are more accurate and encouraged. And the CO2 monitors must be calibrated no less than every 5 years. So it's important that you're getting accurate information, and that's what calibration does for you. A second approach for CO2 monitoring includes buildings with smaller air handling units or split systems, which can use differential CO2 monitoring. This requires CO2 monitors in all occupied spaces, an outdoor CO2 monitor, and a way to provide more air if the difference between spaces meets or exceeds 530 parts per million. For outdoor CO2 sensors, use 400 parts per million as a constant outdoor value based on its support by California's Title 24 Energy Code. California has stringent codes on this because sometimes their outdoor air is very contaminated depending on what part of the city you're in. Could also do conservative set points based on ambient CO2 levels. Core and shell ventilation airflow monitoring includes measuring the direct airflow rate at all expected system operating conditions within an accuracy of 50% of the design minimum. Remember that accuracy percent, it is important. It's one of those things that can be tested on. Once again, that's why it's in yellow. So it's within an accuracy of 15%. Considerations include measures that enable building occupants to monitor the CO2 in their spaces and specify the control systems to include expansion capability. A good synergy with Energy and Atmospheric Credit 1, optimizing energy performance, is demand control ventilation. So this is good for large spaces with variable occupancy, where the outdoor air rate supplied to an area is based on readings taken by CO2 monitors located within the occupied space. So adjust the ventilation rate based on the changing requirement of the space. Once again, lecture halls is a really good example of this. We have 0 to maybe 200 people in one space. Documentation includes CO2 monitors and airflow sensors and floor plans, building drawings and elevations. It's important to keep in mind that this has to be included in the construction documents and should also be included in the specs and mechanical schedules. Apply commissioning to ventilation systems. There's a synergy with EA Credit 3, Enhanced Commissioning. Confirm alarm system settings meet ANSI and ASHRAE 62.1 standards. And calibrate and check regularly the building automation system to manufacturer's guidelines. Building automation systems, smart buildings, can really help with performance and also meeting this indoor air quality requirements in multiple credit categories. Benefits include avoiding headaches, dizziness, and increased heart rate due to high levels of CO2. That's why performance goes up. I've been in offices with bad indoor air quality, and I definitely felt my performance go down after being in that room for a few hours. The result is increased productivity and reduced absenteeism for good indoor environmental quality areas. So for offices, there's a return on investment for actually installing these type of strategies. Related credits include Credit 2, coming up next, increased ventilation, commissioning, prerequisite, and enhanced commissioning credit, measurement and verification credit, and also alternative transportation. Because if you have low emitting vehicles, you have better outdoor air quality, which allows for more natural ventilation to come into the building. The second credit is increased ventilation. 1 point available for new construction, schools, and core and shell. Case 1 refers to mechanically ventilated spaces. The requirement is to increase breathing zone outdoor air ventilation rates. Remember that breathing zone is within 3 to 6 feet above the finished floor area. So you need to increase the ventilation rate to all occupied spaces by at least 30% above the minimum rates required by Environmental Quality Prerequisite 1, according to ASHRAE Standard 62.1. So the important thing to memorize for this credit is the 30% increase in outdoor air ventilation rate above the ASHRAE Standard 62.1. For naturally ventilated spaces, you need to determine if it's a viable strategy first using the flow chart in CIBSE AM10, which is the Chartered Institution of Building Services Engineers. Memorize these two standards. The second is a Carbon Trust Good Practice Guide. This includes recommendations and guidelines So the requirements for naturally ventilated spaces includes compliance path in Chapter 2 of the SIPSI manual, using the method strategy with diagrams and calculations to show the design of the natural ventilation system meets the standard. Option 2 is a macroscopic multi-zone analytic model to predict that room-by-room airflow to show that it will effectively naturally ventilate and prove that 90% of the occupied spaces meet ASHRAE 62.1, 2007, Chapter 6. There's great computer simulation modeling that can help with this and could actually coordinate with the energy model simulation done for optimized energy performance credit. It's important to talk to your engineers early on about how you're going to show this compliance for your building. SIPSI AM10 natural ventilation. Option 1 method strategy includes establishing required flow rates through each space with building orientation, glazing ratios, vents or louvers. Then you need to summarize internal heat gains and weather conditions, and then explain your ventilation strategy, including airflow paths, the rates planned for different operational periods, the peak internal temperatures, and shading summer gains. SIPSI AM10's analytical model is option 2, including the macroscopic multi-zone analytical model. Remember, that standard is the macroscopic multi-zone analytical model. Similar narrative requirements as a method approach, except you need to demonstrate that 90% of the occupied areas are effectively ventilated and provide a room-by-room outdoor airflow rate as predicted by this standard. And this standard is Volume A of the SIPSI Guide, ASHRAE 62.1, Section 6.2. This credit is heavy in memorization. Anything in yellow or orange, make sure to review. 8 steps are provided for natural ventilation guidelines through the Carbon Trust Good Practice Guide. First, you develop design requirements. Next, you plan airflow paths. Then identify building uses and features that might require special attention. To determine ventilation requirements, estimate external driving pressures, select types of ventilation devices, size ventilation devices, and then analyze the design. So the Carbon Trust Good Practice Guide has recommendations that build off of these 8 steps as well. The ultimate benefit is reducing sick building syndrome. Research indicates that improved indoor air quality improves employee health, welfare, and well-being and productivity. Less sick days equal better bottom line for your business, including more productivity and also happier employees. Don't be this guy with the large aspirin bottle every day with ice on your head. I have been there, done that, got the t-shirt, don't recommend it. Now I'm in the EcoTrust building, which has fantastic indoor air quality and is one of Portland's greenest buildings. I actually sublease from Cascadia Green Building Council, and they are very much walking the talk, and I'm reaping the benefits in my business. My employees and I both have noticed increased productivity and better state of well-being from being in this green building. So I can vouch for this benefit. Indoor environmental quality, increased ventilation trade-offs could have to do with optimizing energy performance, since higher ventilation could require more energy. Although there are ways to mitigate this, one solution is heat recovery, which minimizes the additional energy consumption associated with higher ventilation by utilizing waste heat. So you can still get that 30% greater ventilation rate on top of the 62.1 code and still keep your energy efficiency at a high level by preheating fresh outside air with the stale exhaust air. Here's an example diagram of how that works in a heat recovery system. Indoor environmental quality credit 3.1 and 3.2 have to do with construction indoor air quality. It includes an indoor air quality management plan during construction and also criteria for before occupancy. Indoor environmental quality, credit 3.1, construction indoor air quality management plan during construction. There's 1 point available for new construction in schools, but there's different criteria for core and shell. The requirement is you need to develop and implement an indoor air quality management plan for the construction and pre-occupancy phases of the building. I've included an example of that in your study material. And the requirement is during construction meet or exceed Sheet Metal and Air Conditioning Contractors National Association, SMACNA. Remember to memorize standards in yellow. So part of that SMACNA standard says you need to protect stored, on-site, or installed absorptive materials from moisture and damage. So in order to do this, you need to sequence the installation materials to avoid contamination of absorptive materials such as insulation, carpeting, ceiling tile, and gypsum wallboard. So this is really just ensuring best practices on site. And this takes some pre-planning, especially in climates that rain in many seasons. Another requirement of SMACNA guideline is to protect HVAC. Do not use permanent air handling systems. Instead, use temporary ventilation units, as shown by these Sunbelt units in the image. And if the permanent air handlers are used, there needs to be a filtration media with a minimum and efficiency reporting value, known as MERV, of at least 8 that needs to be installed at each return air grill. And then you need to replace these filters before occupancy. So remember that these filters need to be switched out if the permanent air handlers are used during construction. If you're trying to achieve indoor environmental quality credit 5, these filters that are installed before occupancy need to be a minimum MERV rating of at least 13. Remember those MERV rating numbers for each credit for the test. For implementation, pathway interruption is also outlined in the SMACNA guidelines. Depending on weather conditions, the contractor should use 100% outside air to exhaust contaminants directly outdoors during installation of VOC materials. So you want to spec low emitting materials, but if some materials are emitting some VOCs, you want to make sure to be exhausting that out. During construction, you want to isolate areas of work to prevent contamination of clean or occupied areas, or else that gypsum, wallboard, or carpets will absorb those contaminants and then emit those when the building is occupied. So you want to depressurize the work area to contain dust and odors, provide temporary barriers to contain the construction areas. Implementation of the source control component of the SMACNA guideline includes isolating and ventilating containers using toxic materials or housing toxic materials. Select low-emitting materials such as paints, carpet, composite wood. And this has synergy with Indoor Environmental Quality Credit 4, low-emitting materials. The construction management plan should include control measures for volatile organic compounds, known as VOCs, and exhaust fumes from gasoline and diesel engines outside the building. This includes a lot of coordination on site with the contractor. There's a lot of quality control involved. The superintendent really needs to be on board to meet this criteria. And pictures need to be taken at various stages to ensure that this was done. Next slide. Implementation of the housekeeping section of the SMACNA guideline. You need to protect porous materials from exposure to moisture. Store these items in a clean area before install. And use HEPA filter equipment, vacuum cleaners, and wetting agents to control dust. Implementation of the scheduling section of SMACNA includes coordinating filter replacement, around Indoor Environmental Quality 3.2 Indoor Air Quality Management Plan before occupancy, and also the criteria of the Indoor Chemical and Pollutant Source Control Credit number 5 of this category, which requires MERV 13 filters. For credit 3.2, the requirement is MERV 8. You need to plan for construction with potential pollution during unoccupied hours, such as evening and weekends. You can see how this criteria really needs to be integrated with your construction management. It's important to refer to the control measures in SMACNA's Indoor Air Quality Guidelines for occupied buildings under construction. It provides an overview of air pollutants associated with construction control measures, construction process management, quality control, communication with occupants, and case studies. So it's a great reference for creating a healthy environment, ultimately for the building tenants, but also for the contractors on site as well. For the submittal, you need to provide a copy of the Indoor Air Quality Plan and confirm if the permanently installed air handling equipment was used during construction. If so, then you need to replace those filters. It's especially important for the contractor to understand that they need to keep a detailed photo log to highlight construction indoor air quality practices that were specified in that construction indoor air quality management plan. If they didn't keep photos of it, they won't be able to achieve this credit, even if they did do all those procedures. So they need to understand their roles and responsibilities on site, and those photos need to be dated and taken at various times during construction. Indoor Environmental Quality Credit 3.2 is Construction Indoor Air Quality Management Plan before occupancy. This requires a building flush-out. Path 1 for achieving this credit includes after construction ends, prior to occupancy, and with all interior finishes installed, performing a building flush-out that supplies a total air volume of 14,000 cubic feet of outdoor air per square foot of floor area. And you need to maintain an internal temperature of at least 60 degrees and relative humidity no higher than 60%. Memorize those numbers in yellow. Path 2 for the flush out is if occupancy occurs prior to completion of the flush out. You need to first deliver a minimum of 3,500 cubic feet of outdoor air per square foot before the occupants move in, and then once occupied, ventilate at a minimum rate of 0.3 cubic feet per minute per square foot of outside air, or the design minimum for indoor environmental quality prerequisite 1, whichever is greater. So always going for the more stringent criteria. You can see how this takes possibly a longer period of time. The ventilation must begin a minimum of 3 hours before occupancy and continue during until that 14,000 cubic feet per square foot is met. Option 2 is air quality testing that's done after construction ends and prior to occupancy, and uses the protocols within the Compendium of Methods from the United States Environmental Protection Agency. In this case, you have to demonstrate that contaminant maximum concentrations are not exceeded, and if they are exceeded, a flush out is required in that area, and you have to continue to take air samples of those spaces until all areas comply. This option is often more expensive, and it can be more unpredictable if all areas are going to comply or not, opposed to just a flush out of the whole building. For the flush out procedure, all construction punch list items should be done. And you also need to address future tenant build outs. You're really trying to ensure that the final product is a healthy indoor environment. So if you use the building HVAC system after it's been balanced and tested to evacuate airborne contaminants, you need to remove duct coverings, remove temporary filter, and install new before occupants are in the building. Once again, if you are trying to attain Environmental Quality Credit 5, the MERV rating is 13, And if you're just trying to meet this credit criteria, it's MERV 8. Remember those two MERV rating levels. Alternative approach is to use temporary supply and exhaust systems placed in windows or other penetrations. This is often a more recommended path. For air quality testing option, this is conducted with the HVAC system operating under normal conditions with outdoor airflow rates at the minimum. So really you're testing the worst case scenario. Similar to the flush out, all interior finishes must be installed, furnishings as well if possible. It's important to memorize this criteria. Samples should be taken in each portion of the building being served by a separate ventilation system. There must be at least one for 25,000 square feet. The locations of the air quality samples should be in the breathing zone between that 3 and 6 feet above the finished floor and be a minimum of 4-hour duration. You need to record your exact locations in case you need to retest an area that does not comply and perform a flush out. Verification and documentation is critical for these credits, and memorize all those items in yellow. When deciding which option to take, there's always a cost-benefit analysis. For flush out, it's often used when building occupancy does not need to happen directly after construction completion, or else it can take a long period of time to hit that 14,000 cubic feet per square foot. Indoor air quality testing can avoid schedule conflicts, but can be more costly.